Unit 10 is solving radical and rational equations. And then 10.1 is specifically solving radical equations, level 1 and 2. So radicals are having those square root symbols, cube root. We're only going to be dealing with square roots. And then rationals we'll get to when we have fractions. And directions say to solve for all possible values of x, watch out for what's called extraneous solutions. These are when we get answers, but when we check them or plug them in, they don't work. And so then we just kind of discard those answers. They don't actually count. Okay, so unfortunately you will have to check them, but you could just check on a calculator. So number one, if I have an equation here, I'm trying to figure out 7 times what number minus 17, when I take the square root of that and then add 19, equals 21. And so just like when we solve any equations, we want to try to peel back the layers or the things that have happened to x in an opposite order than what happened to them to try to get x by itself. So the first thing I would do is think of this is all grouped together. I would want to get rid of this plus 19 so I can at least isolate or get the square root by itself. Remember, we do inverse operations or opposite, so I would subtract 19 on both sides to make that cancel. 21 minus 19 would be 2. Drop down what you still have. Square root of 7x minus 17. I cannot add 17 yet because it's under a square root. So to get rid of a square root, I want to do the inverse of that, which is squaring. And what I do to one side, I must also do it to the other. So a square and a square root are going to cancel each other out and bring out the 7x minus 17. And then 2 squared is 4. Now it becomes just a normal equation. So I would add 17 to 4, 17 to 4, which is 21. Bring down your 7x, divide by 7, so x must be 3. So when you go to check, you would have square root of 7 times 3 minus 17, and then plus 19 needs to equal 21. Okay, I could go on and probably do this faster in my head. 7 times 3 is 21. 21 minus 17 is 4. Square root of 4 is 2. 2 plus 19 does equal 21. So that's good. All right, number 2. This is actually a level 2 problem because now I don't see just a number over here. I see x plus 1. The good news is, though, nothing is outside the square root function. And so I'm ready to try to get that x out from under there. So I'm going to go ahead and square this side so that I can cancel out that square root. But what I do to one side, I must do to another. And I can't simply pick and choose whether the x or the positive 1 gets squared. It's this whole quantity, this whole amount gets squared. So I'm going to have to FOIL on this side. So then that brings out the 9x minus 9. However you want to FOIL this, but remember squaring just means it's times itself. So that would give me x times x is x squared. Outers is a 1x, inners is a 1x, that adds to make 2x, and 1 times 1 is 1. So what you have now created is a quadratic because I see a term being squared. We can only solve this by setting it equal to 0 and trying to factor. So I'm going to try to get everything on one side. I'm going to subtract the 9x and add the 9. So that makes a 0. 2 minus 9 is negative 7x, and 9 plus 1 is 10. So we've got to figure out what two numbers multiply to make positive 10 that add to make negative 7. It's going to have to both be negative numbers, and it'd be 5 and 2. That means we're getting two answers. If x is 5, that would make that factor be 0, and if x were positive 2, it would make that factor be 0. You're going to have to check both of them. And the way I would do that, if you just want to do it on a calculator, is do your square root button, 9, then you do parentheses or times, I just like parentheses better, 5 minus 9. All that should be under the square root, and see what that is. That's 6. If I were to plug 5 in right here, 5 plus 1 also equals 6. So I get a statement that 6 is equal to 6, and that works. Then I would do the same thing for the 2. I should be able to come up here and steal this, change the 5 into a 2 so that I have a 9 times 2, which is 18. 18 minus 9 is 9. I'm square rooting that, so I should get 3. If I plug in a 2 here, 2 plus 1 also makes 3. Both sides come out to be the same number, so I get these two answers that work. All right, number 3 starts out the same way. We have nothing outside of the square root, so there's no getting this by itself. We're just ready to go ahead and get rid of the square root by squaring. Square and square root cancel, so I bring out the 3x minus 8, FOIL that somehow. I'd get an x squared. I know I'd have a negative 4x and a negative 4x, that makes negative 8x, and negative 4 squared is positive 16. Get it set equal to 0. So I get x squared minus 11x plus 24. Factor. It'd have to be two negatives again. That would be negative 8 and negative 3. Which mean my solutions get positive 8 and positive 3. So let's try it on this one. You're going to have the square root of 3 times, we're going to plug in 8, minus 8. That comes out to be 4. And if I plugged in 8 here, 8 minus 4 is also 4. So that one definitely works. Plug in 3. And again, I can almost do this faster. 3 times 3 is 9. 9 minus 8 is 1. Square root of 1 is 1. 3 minus 4. Be careful there. 3 minus 4 is not 1. It's actually negative 1. So that is not true. 1 does not equal negative 1, so that's called an extraneous solution. So you would only put 8 into Delta Math as your answer. All right, and then one more. Ready to square both sides. I'll let you go ahead and do that part real quick. And you should have got x squared minus 14x plus 49 for your foiling. And then get everything set equal to 0. That would be a minus 5x, and then that would be, what, negative 6? Be careful when it's 6. We always have trouble deciding between 1 times 6 or 2 and 3. In this case, I'm going to need a positive and a negative number, and so I need them to subtract to make 5. So that would have to be negative 6 and positive 1. So then that would get solutions of 6 and negative 1. Let's try it. So I would have 55, underscore root 55 minus 9 times 6, which 9 times 6 is 54. So 55 minus 54 would be 1, square root of 1 is 1. And then if I have 6 minus 7, that gets negative 1, so that does not work. And then plug in the negative 1, that would be 55 minus 9 times negative 1, which that would be 9. 55 plus 9 would be 64, square root of 64 is 8. If I were to plug in negative 1 here, that would be negative 1 minus 7 more, which is negative 8. That's not true either. So actually, there's no solution to this problem. So on Delta Math, you would just type in nothing and submit an empty set.